Have a very simple video for you today. We are just going to be solving a bunch of differential equations, standard stuff. I'm calling this part 2 because a while back I posted a video that I called Differential Equations in 30 minutes, in which I solved what was, up until then, all of the differential equations that had appeared in IB, Math, AA, HL exams. Since then, there have been a couple more exams, so those are the differential equations that we are going to be solving today. In that first video, as I was solving the equations, I was also kind of going through the explanations of the steps and the procedures of how you solve differential equations. I think I'm going to be doing less of that today because I already did it the other time. So if you are still a little bit confused on the procedures and you feel like I'm going too fast today, then I recommend that you watch part 1 first. It is, of course, linked in the description of this video. So at that time, when I said that I was solving every differential equation that had appeared in exams, that was in kind of a loose sense. For example, this one I solved in the first video, but it did appear a couple of more times in other exams, not exactly like this, but variations of this same equation. I'm not going to cover it today because I already did that. I just wanted to point out that this equation is a favorite of theirs for good reason, because it turns into the logistic equation, which, since I posted the other video, I also addressed this as the logistic function in another video, which I'm linking down below. So if you're interested in that, go check it out. Today we are starting with this one, which is from a recent exam. But I would also like to point out that if you're studying differential equations and you're taking your studies seriously, you are not going to be surprised by this equation in an exam, right? It looks pretty simple. dy dx equals x plus y. In fact, this is my favorite example to use when I am first telling people what a differential equation is. Not because it's the simplest one to solve, but because I think it is a pretty equation. X plus y is a simple looking expression. And I do use it as my first example in another video that you might want to watch. But in that video, I did not solve this differential equation analytically by hand, which is what we are going to do right now. So the first thing that you need to do when you want to solve a differential equation is choose what technique you're going to use. And the 3 techniques that we learn how to use in this course are separation of variables, homogeneous equations, and integrating factors. So let's look at our equation. Can the variables be separated? No, not really, because the plus is a very big indication that that's not going to work. What about a homogeneous equation? Is that equation homogeneous? Well, homogeneous equations are when the whole equation has y and x appearing only as y over x or x over y or variations of that. And this is not the case. So this equation is not homogeneous, which leaves us with no other option but to try to find an integrating factor. Integrating factor is not my favorite technique. It appears in the formula booklet in exactly this way. And I've talked about in another video before how I don't even like to explain integrating factor anymore. When I come to this point in the high-level course, that's at the very end of the course, the students have learned so much already that I am fine with just telling them, listen guys, this is one of the most difficult things in the whole syllabus. You've learned so much math over the past 2 years. I know that you are capable of understanding concepts, and we have this big exam right around the corner where this is just a tiny little piece. I'm not sure if I've ever even seen this used in an exam question. So in those conditions, I feel pretty comfortable telling my students, I'm not going to explain to you where this comes from. It's just one of the methods of solving differential equations. When it's this type, just do this and you're done. Because this is in the formula booklet anyway, but I did explain it in the first video about differential equations. But the thing is that you are trying to get that to be a sort of product rule thing like this. Then the product rule means that it would look like this. You just divide everything by f. And then the f prime divided by f becomes the p that they are talking about. But then you kind of need the f prime divided by f to be equal to p, right? And then if you think about the chain rule, this is the derivative of this. So then you integrate both sides And then putting both sides in the exponent of e gives you the thing that is in the formula booklet. Today I'm just going to use this to solve our equation. So the first thing that we need to do is to make sure that that is looking like this. So the part that has a y is supposed to be on the left together with the derivative. Our equation is looking like that, with the p of x being minus 1 and the q of x being x. Now we need to find the integrating factor, which is going to be this. Like I mentioned, because the p of x is minus 1 here, so I've put the minus 1 into this formula. That's an easy integral. The answer is minus x. And just a little comment here, because I know that some people wonder about these things. When we do this integration in the exponent for the integrating factor, don't we need to put a plus c since it's an indefinite integral? And the thing is that we don't, because a plus c in an exponent is actually a times a constant. And what we're going to do with this integrating factor is to multiply both sides of the equation by it. So if we multiply both sides of the equation by an extra constant, it's not going to make any difference in solving the differential equation. So after multiplying both sides of this equation by this integrating factor, we get this. And then the next thing that we are supposed to do is to observe that the left side of the equation has turned into something that looks a lot like the product rule. It's the derivative of something that was a product. So in this case, it was this, because when you take the derivative of y, it becomes this term. And when you hold down the y and take the derivative of this, it gains the negative sign, which comes here by the chain rule. And the right side of the equation is just going to be the same. So from here, you can just think that you are going to integrate both sides of this equation dx. On the left side, this cancels out because it's the integral of somebody's derivative. And on the right, you just have to use integration by parts on that integral. I have chosen these parts. So f is x, f prime is 1. G prime is that exponential, so g is this one. And now I'm going to put that into the integration by parts formula. That final term becomes an easy integral. And that is the moment where the plus c is supposed to appear, because it's when you've finished integration. But you were trying to find y in terms of x. So now let's isolate this y by multiplying both sides of the equation by e to the power of x. And that is almost the final answer to the question. It's only not exactly finished because the question did give us an initial condition, y equals 2 when x equals 0. So we are supposed to plug those numbers in here to figure out the value of the constant c. So when I do that, these are going to simplify a little bit because minus 0 doesn't have to be here. E to the power of 0 also doesn't need to be there. And c equals 3. That is the final answer to this question. I think this was like 7 marks or 8 marks. Definitely something that is worth knowing how to do well. This is easily an exercise that you did at home before going into the exam. And then you go to the exam and it's worth 7 or 8 marks. That is very good. Okay, so this one is recent as well. It is worth fewer marks, just 5, because it is a lot easier, isn't it? This is just a separable equation. You just switch your variables around so that all of the y's are on the left and all of the x's are on the right. But don't leave a whole line like that. Put the integration signs on both sides. Otherwise, it's technically wrong notation and they don't like it very much when you do that. But now it's just 2 easy integrals to solve. The one on the right is extremely easy, right? For the one on the left, you could write out u substitution with u equals 4 minus y. That's just going to turn into the integral of 1 over u, which is log. I'm going to leave those absolute values in there because technically they are there, but you'll see that they don't really matter that much. What I have to do now is to isolate y in this equation. So let's start by multiplying both sides by -1. You don't have to change the sign of the constant. It's just a negative constant. And now we're going to use the definition of log here to get the y from inside of the log, get it out. This constant that is adding in the exponent, again, I think I've mentioned this before today. This is just a constant that is multiplying the exponential. And that's why that absolute value doesn't really matter, right? Because that's plus or minus this, but you can just put the sign into the constant anyway. So that is the almost final answer here. Now we need to put the initial condition into that in order to find the value of the constant. Yeah, so that e to the power of 0 is just 1, and clearly the constant needs to be a half. So here is the final answer to that question. This one is not from a recent exam. This one is actually from one of the specimen papers that they wrote even before first assessment of the current course. I don't remember why I chose not to include it in the first video, but anyway, here it is. A clear example of homogeneous equation. I don't remember if the question said so, sometimes they do, but it's very clear that this is a homogeneous equation, because if you separate that fraction into 3 fractions, you get that, and then some things cancel out, and you get this. So the whole equation is depending on y and x, only as in y over x. There's a y over x here, which happens to be squared, but that doesn't matter. And there is another y over x here. So that is the homogeneous situation, and you go forward from here by doing a substitution. Y equals vx. And I am writing it as y of x and v of x here just to highlight the fact that these are functions of x, like v is not a constant. But moving on, when I substitute it into the equation, I am going to shorten the notation by just saying v and v. I'm not going to write v of x. And I'm not writing y of x either. That is the standard notation that we use in these situations. But I do still need the derivative of this in order to substitute in there. So let's do the product rule here to find y prime. That's the result of the product rule. So this is that is equal to this. And the nice thing about homogeneous equations is that after you do this substitution, it always turns into a separable equation. So that is something that you can also use to check if you've made a mistake. Like if you get to this point and your equation is not separable, then you've done something wrong, or it wasn't a homogeneous equation to begin with, but in this case we knew it was. So how are we going to separate our variables? First, I'm going to subtract this v from both sides. I'm going to write the v prime as dv dx. And then I'm going to switch the variables around just like I did in a previous example. Just again, make sure that you include the integration signs on this line. And that integral is easy. That is ln x. This integral, on the other hand, is not quite as easy. In fact, I am questioning myself here whether I have copied the question correctly when I was preparing for the video, because it is a little surprising to me to come to this kind of situation. I'm gonna solve it, but just keep in mind that we're maybe solving the wrong equation. And let me know if that's the case. Point it out in the comments. But the thing is that this has a quadratic function in a denominator. It is the kind of situation that looks like partial fractions, and partial fractions appears quite often in differential equations exercises. But this quadratic function doesn't have zeros. The discriminant is a negative number. So I can't start my partial fractions process by factoring the denominator like I usually do. So instead, I'm going to do something else. I'm going to complete the squares of that denominator. And here's how I like to do that. I just write out the conclusion that I want to come to. I want to find the values of h and k. Now I'm going to expand this, and I'm going to compare the coefficients. So 2 needs to be the same as minus 2h, which tells me that h needs to be -1. And then if h is -1, then h squared is 1. So 1 plus k is 2, which means that k is 1. Now I'm going to put those two numbers into here and substitute that back in place of this in that denominator. Now, instead of looking like partial fractions, that is supposed to be looking like arctangent, but it's arctangent of v plus 1. And if you're not comfortable doing the u substitution here that fast, by all means, slow down and call u equals v plus 1 and do all of the steps. Yeah, so even though it's going to look horrible, I don't think there's any issue preventing us from isolating v in terms of x in this equation. right? So I did the tangent on both sides of the equation, and then I subtracted 1 from both sides of the equation. Now I need to remember where this came from. I am not actually looking for v, I'm looking for y, and y is v times x. So I just need to multiply both sides by x now. And I do still have a point that the question gave me so that I can find the value of the constant. So let's put x equals 1, y equals -1. Okay, ln of 1 is 0, so that's just a tangent of c. Now I can add 1 on both sides here. Tangent of c is 0 is going to be fine when c is 0. I don't like it when c is 0, because then the student who just forgot to put the plus c and didn't even bother substituting the point in the end is going to come to exactly the same conclusion, and he's going to be confused as to why he didn't get all the marks if he got to a 100% correct answer. Okay, one more. The only one from today's list where the letter x is acting as the dependent variable instead of the independent variable, okay? So all of the other ones in the video were dy dx. This one is dx dt. Whatever is going to be exactly the same thing. I'm just saying, pay attention, because sometimes it's one thing and sometimes it's the other. This one is clearly integrating factor because one of the terms being added here depends only on the independent variable. That's going to be the q of x from the formula booklet, but in this case it's q of t. And the other thing being added has the dependent variable multiplied by another function of just the independent variable, which in this case it's 1 over t plus 1. So let me reorganize it in the way that you want to see it from the booklet. You reorganize it like that. So this is p and this is q, meaning that the integrating factor is e to the power of the integral of that. That integral is also easy. It's just ln, which makes it even nicer because e to the power of ln. So this integrating factor is just t plus 1. I'm going to be multiplying both sides of the equation by t plus 1. When I do that, this part cancels out, and that part is supposed to look like the derivative of somebody using the product rule. That's t plus 1 times x, right? When you take the derivative of x, you get the x prime, and when you hold down the x, take the derivative of t plus 1, that's just 1. And that is equal to this side. So now we are going to integrate both sides dt, and on the left side, that is going to cancel with the derivative. Let's get this tan out of here. It's an annoying little integral, but we can do it by parts. So these are the parts. The derivative of t plus 1 is 1. The integral of this is that with the -4 coefficient. Plugging into the integration by parts formula, we get this. And finally, when we integrate this last part, we are going to get yet another constant of -4. So that's going to be -16, not forgetting the plus c. And now we divide both sides of the equation by t plus 1. This one's going to cancel out, and there is going to be a t plus 1 here, and also on the constant. I don't think this question had an initial point to substitute to find the value of c. At least if it did, I forgot to copy it. And finally, we have this one, which is also from a recent exam. It's a very fun differential equation, but I'm not going to do it right now because I've already done it in a previous video. So I am just going to put that part here and add a link to the full video in case you want to see the larger context of the question in which this appeared, what they were talking about. The standard trick to solve homogeneous equation is to consider this kind of substitution here. Then you take the derivative. This, of course, requires the product rule. And now you're just going to substitute these things into that equation. There is a cancellation of x divided by x to be done on the right side. And from here on down, it's just separation of variables. We're going to begin by subtracting u on both sides. Now we're going to put these two things under the same denominator. I'm going to multiply both sides by -1 because this is making me nervous, but you absolutely don't have to. Now let's move things around to separate the variables. This integral is easy, that one not so much, but I want to separate it into two integrals, u over the denominator plus 1 over the denominator. like that. So this is easy. It's just ln x. I'm going to put the plus c here. This one is easy as well because this is just arctangent. And that one is not so difficult. You just do a substitution of v equals u squared plus 1. So nothing individually difficult here, but I kind of think that the idea to split it up is a little bit difficult. I don't think a lot of people think of doing that when they see an integral. They want to do just the whole thing as one function, and I am not really sure how I would have done that in this case, especially after seeing the answer where one part became an arctan and the other part became an ln, so I don't know. And that's pretty much it. We still need to organize it a little bit to get it into the format that he wants. So first I can add ln x on both sides. Of course, I need to substitute back u equals y over x, which was the substitution that I did for the homogeneous. And that's it. So if you came this far and you left there nervous because you know that there is technically a step missing after we do the differential equation, we still sometimes want to isolate y in terms of x. And this looks like a terrible expression to try to do that in. I just hope you didn't waste precious minutes during the exam trying to isolate y in terms of x here, because it's not going to happen. And the good news that I have for you is that there's nothing missing. This is already the 9 marks because he did say to give the answer in the form h of x and y, which is this function of two variables here, equals a constant. He did that because he knows that y cannot be isolated in terms of x here.